at least 3 months of experience programming in JavaScript. So in this section, I'm going to cover the essential JavaScript features that you're going to use a lot in React applications, such as let versus const keywords, objects, the this keyword and how it behaves differently, arrow functions, object destructuring, the spread operator, classes, and modules. Make sure you know all these topics well before going further, otherwise you're going to have a lot of difficulty later down the road. I just need to clarify that in this section, I'm not going to go really deep in these concepts because this is a React course, not a JavaScript course. As I told you before, I've got 2 other JavaScript courses for you. One is called JavaScript Basics for Beginners, and the other is Object-Oriented Programming in JavaScript. The focus of the first course is on the art of problem solving. It teaches you how to think like a programmer. Unfortunately, there are a lot of developers out there in the industry who can build applications with Angular, React, and all kinds of fancy frameworks, but they cannot solve simple programming problems. Because they're self-taught programmers, they have never attended a college or university, they never learned the fundamentals of computer science and software engineering. And that's why I've designed this course. The focus of the second course is on more advanced topics such as constructor functions, objects, prototypes, inheritance, polymorphism, classes, and more. All right, that's enough introduction. Now, let's get started. To demonstrate the modern JavaScript features, I'm going to use a brand new React project. So in this project, let's open up index.js and delete all the code here and focus on plain vanilla JavaScript. So the first thing we're going to look at are the new keywords for defining variables and constants. So let's define a function, call it say hello. Here I'm going to define a loop. So for var I, we set this to 0. As long as it's less than 5, we increment I and log it on the console. Pretty simple, right? Let's call this function, save the changes, back in the browser. So here we see these numbers 0 to 4, pretty straightforward. However, there is a problem with the var keyword in JavaScript. In most programming languages, when we declare a variable, that variable should only be accessible in the block in which it's defined. This is what we call scope, right? So in this case, I should only be accessible inside of the for block. However, I can come here and log I on the console and you will see that I is still accessible here. Save the changes, back in the browser. Look, we've got I displayed here because in the last iteration, I becomes 5, and because 5 is not less than 5, we exit this loop. So this is what I want you to take away. When you declare a variable with the var keyword, that variable is accessible inside of the function in which it's defined. And this is one of those weird things about JavaScript that is different from other programming languages. So in ECMAScript 6 or ES6, which is the version of JavaScript introduced in year 2015, we got a new keyword for declaring variables, and that is let. So let came to solve this problem. When you declare a variable with the let keyword, that variable is only accessible inside of that block. Let's see the result. So save the changes, back in the browser. Now we get this error on the console. I is not defined. So here's what I want you to take away. Variables declared with the var keyword are scoped to the function, whereas variables declared with the let keyword are scoped to the block in which they are defined. So going forward, you should prefer to use the let keyword unless you have a very valid reason for using the var keyword. Now we also have another new keyword in ES6, and that is const. We use const to define constants. I'm going to show you that in a second, but similar to let, variables defined with const are also block scoped, so they're only accessible inside of the block they're defined. Now let me show you the difference between let and const. So I'm going to delete all this code here. Let's define a variable with const, set it to 1. Now if we reassign this and save the changes. Back in the browser, you can see that X is read-only. In other words, when you declare a variable with the const keyword, that variable cannot be reassigned. That's why we refer to that as a constant. So technically, it's not a variable because it cannot change. It's a constant. So let's quickly wrap up. Throw away the var keyword and prefer to use const over let. Use let only when you need to reassign a variable. All right, now let's take a look at objects. So once again, I'm going to use the const keyword to define a variable, well, more accurately, a constant, and set it to an object. So as you know, objects in JavaScript are collections of key value pairs. So I'm going to add a couple of key value pairs here. The first one is name, which was set to a string, and the second is walk, which was set to a function. Now, in object-oriented programming terms, if we have a function inside of an object, we refer to that function as a method. So here we say walk is a method in the person object. Now, starting from ES6, there is a cleaner and simpler syntax to define a method in an object. So let's add another method here. I'm going to call this talk. Now here we don't need to add a colon and the function keyword. We can define it like this. So basically, we drop the colon and the function keyword, and here's the result. So here we have a person object with 3 members, 1 property, and 2 methods. There are 2 ways to access these members. We can use the dot notation, which you are probably familiar with. So dot, talk, or walk. We can also use the bracket notation. So person, we add square brackets, pass a string, and this string determines the name of the target member. So if you want to access the name property, we pass that here. And now we can reassign that to a different value. In terms of practicality, we use the bracket notation when we don't know ahead of time what property or method we're going to access. Let me show you what I mean. So I'm going to define a constant, call it target member, and set it to name. Imagine this target member is an input field on a form. Depending on what the user types in that input field, we're going to access a different property in this person object. That's when we use the bracket notation. So instead of hard coding name here, we pass target member. And once again, this could be an input field, so we could access the value property like this, and then dynamically access a property or a method in an object. If we know ahead of time what property or method we're going to access, we use the dot notation. So we write person.name, we set it to a different value. Next, we're going to look at the this keyword in JavaScript. So we have this person object with a walk method. Now let's modify this method and do a console.log of this. What is this? This is a special keyword in JavaScript which confuses a lot of developers because it doesn't behave the same as this in other programming languages like C# or Java. In these languages, this always returns a reference to the current object. Let me show you. So here, I'm going to call person.walk, save the changes, back in the browser. So we see our person object on the console. So in this case, this is returning a reference to this person object, right? However, this in JavaScript does not always work that way. Let me show you why. So I'm going to define a constant, call it walk, and set it to person.walk. Note that I'm not calling the walk method, I'm just getting a reference to this function. So walk is now a function. Let me show you. So console.log of walk. Now back in the browser. So you can see our walk constant is set to this function, right? Now let's see what happens when we call this function. So I'm going to call walk, save the changes, back in the browser. What's going on here? So we don't get a reference to the person object. We get undefined. That's why I told you that the this keyword in JavaScript behaves differently from other programming languages. The value of this is determined by how a function is called. If we call a function as a method in an object, this will always return a reference to that object. However, if we call a function as a standalone object or outside of an object, this will return the global object, which is the window object in browsers. But in this particular implementation, we didn't see the window object here, we got undefined. The reason for this is because in this React project, the strict mode is enabled by default. If you're not familiar with the strict mode, it's basically a mode to execute JavaScript code in a more protective way. So it prevents potential problems. That's why, in this case, instead of getting a reference to the window object, we get undefined. So in the last lecture, you learned that when we call a function as a standalone function outside of an object, this by default returns a reference to the global object, which is the window object, and if the strict mode is enabled, it returns undefined. In this lecture, I'm going to show you how to fix this problem, so no matter how we call the walk function, this will always return a reference to this person object. So one thing that might be new to you is that in JavaScript, functions are objects. So here, person.walk is actually an object. Don't believe me? Let me show you. So dot, look, these are all the members of the walk object. So every function in JavaScript is an object with these members. We've got this method here, bind, and we can use this method to bind a function to an object. What do I mean by this? So when we call this, note the first argument is called this arg. What we pass here as an argument will determine the value of this. In this case, if I pass this person object here, the bind method will return a new instance of this walk function and set this to point to this person object. So now when we call this walk function, we will see this person object on the console. Let's have a look. Save the changes back in the browser. Look, the bind method fixed our problem. So let's quickly recap. Functions in JavaScript are objects. They have properties and methods we can use. One of the important methods that you see in a lot of React applications is the bind method. With the bind method, we can set the value of this permanently. So when we call bind on the walk function, we get a new walk function, and in that walk function, the value of this is based on the argument that we pass to the bind method. So because here we're passing the person object as an argument, we'll get a walk function that is always attached to this person object. And that's why when we call it here, without a reference to the person object, we'll still see the person object on the console. One of my favorite features in modern JavaScript is arrow functions. So let's define a constant, call it square, and set it to a function that takes a number and simply returns number times number. So this is the old JavaScript. Now, starting from ECMAScript 6, we have a cleaner way to write the same code. So let me duplicate this so you can see both versions side by side. To convert this function to an arrow function, we get rid of the function keyword and put a fat arrow between the parameters and the body of the function. Now, if we have only a single parameter, we can exclude the parentheses. If we have 0 parameters, we have to add empty parentheses. So this is a function that takes no parameters, okay? Now, let's revert this back. We have a single parameter number. Now, if the body of our function includes only a single line and returns a value, we can make this code even shorter. We can get rid of the return keyword as well as the curly braces. And this is the end result. So the code we have on line 5 is exactly equivalent to what we have here. You can see the syntax is cleaner and more compact, and you can read it like number goes to number times number. So we can call this square function like this and log the result on the console. And let's remove this. Otherwise, we'll get an error because we have declared the square constant twice. So save the changes. Back in the browser, we get 25 on the console. Now let me show you where these arrow functions are really useful. Let's imagine we have an array of jobs. So each job object has maybe an ID and a property called isActive, which we set to true or false. Now I'm going to add a couple more here and make the first two jobs active and the last one inactive. Okay. Now let's imagine we want to get only the active jobs. So we call jobs.filter method. The argument that we pass here is a predicate function, a function that takes a job object and returns a true or false. So when we call the filter method, this method iterates over this array. For each job object, it takes that job object and passes it to this predicate function. The job of this predicate is to determine if that job object should be returned from the filter method. So here we can return job.isActive. If we return true here, that job will be returned from the filter method. So we can get the final list and call it active jobs. Okay. Now here we have a simple function, and this is a perfect opportunity for us to use an arrow function and make this code cleaner and more readable. So I'm going to duplicate this line so we can compare them side by side. So as I told you, to convert this to an arrow function, we get rid of the function keyword, delete, put a fat arrow between the parameters and the body. Now we have a single parameter, so we can get rid of the parentheses. And we have a single line here. We're simply returning a value. So we can get rid of the return keyword as well as the curly braces. And we don't add the semicolon here. So this is the end result. You can see this code is cleaner and easier to read. So filter jobs where job is active. There is less noise in this code. One thing you need to know about arrow functions is that they don't rebind this. Let me show you what I mean. So I'm going to start by defining a person object. Here we're going to have a simple talk method. Let's log this on the console. Okay, so we call person.talk. What do you expect to see on the console? A reference to the person object, right? Let's make sure everything's working. So back in the browser, so we have this, and next to that we have a reference to our person object, right? Now let's see what happens if we wrap this line inside of a call to the setTimeout function. So as you probably know, in JavaScript we have this global function setTimeout. We can give it a function and a timeout value, let's say 1000 milliseconds. So setTimeout will execute this function after this delay, 1 second, right? Now in this callback function, I want to log this on the console. So previously, when we logged this on the console, we saw the person object. Now let's see what happens when we log this inside of this callback function. So save the changes, back on the console. We get the window object, not the person object. What's going on here? The reason this happened is because here, this callback function is not part of any objects. So it's not like the talk method in the person object. It's a standalone function. And as I told you before, when we call a function as a standalone function outside of an object, by default, this returns the window object. Now, in the previous example, instead of the window object, we got undefined because in that particular case, when we got a reference to a method in an object, the strict mode kicked in and returned undefined instead of the window object. But in this particular case, in case of callback functions, the strict mode does not override this behavior. So this returns a reference to the window object. So how can we solve this problem? In other words, how can we have a reference to the person object inside of this callback function? Well, here's one solution. So in the old days, we used to declare a variable, call it that or self, and set it to this. So we set this variable outside of this callback function. And now we can use self inside of this callback function to get access to the person object, right? So now let's log self on the console. So self and self. Save the changes. Back in Chrome, you can see we have a reference to the person object. So this is the pattern that we used in the old days. Now with arrow functions, we no longer have to do this because arrow functions don't rebind this. In other words, if we change this callback function to an arrow function, it will inherit the this keyword. Let me show you. So I'm going to change this to an arrow function and revert this back to this, right? Save the changes, back in the console. You can see this returns a reference to the person object. In other words, here in this callback function, because we have used the arrow function syntax, this is not reset. Instead, it inherits this in the context in which this code is defined. So this is what I want you to take away. Arrow functions don't rebind the this keyword. ECMAScript 6 introduced a new method in arrays called map. This is a very useful method, and in React, we use it to render lists, as you will see in the next section. So whenever you want to render a list of items, that's when you use the map method of arrays. So let's say we have an array called colors with 3 items, red, green, and blue. Let's imagine we want to render these using list items. So for each color, we want to have a list item like this, right? So we call the map method on this array, colors.map. Here we need to pass a callback function. The job of this function is to transform each element in this array. So this function is called by the map method for each item in this array. It takes one item at a time and returns a new item. So a callback function takes an item and returns a new item. Now in this case, I want to rename this item to color because we're dealing with an array of colors. Now we take a color, which is a string. We simply return a new string like this. We had the opening li tag plus color plus another string that includes the closing li tag. Now this map method returns a new array, so it does not modify the original array. Let's call that items. Okay, now we can simplify this code, we can make it cleaner. So we have a callback function. It's a very simple function and a great candidate for converting to an arrow function. So we get rid of the function keyword and put a fat arrow here. We have a single parameter, so we can get rid of the parentheses. We have a single line where we're returning a value, so we can get rid of the return keyword as well as the curly braces. Put everything on one line, get rid of the semicolon, and this is the end result. So we're mapping or transforming the array of colors. For each color, we return a string like this. Now we can take this to the next level and make this code cleaner. These concatenations here are a little bit ugly. So instead, we can use template literals in ES6. So instead of using single or double quotes, we use the backtick character. That's the character before number 1 on your keyboard. Here we can define a template for our string. So we want to have the opening and closing li tags. And in the middle, we want to render the color dynamically. So we add a $sign and curly braces. This is an argument placeholder. What we put in between the braces will be rendered dynamically at runtime. So here we want to render this color that we have here, right? So this is what we call a template literal. Now we get a new array. Let's log that on the console. So console.log items. Save the changes. As you can see, we have an array with 3 items. So this map method is very useful in React when rendering lists, as you will see in the next section. One of the modern JavaScript features that you see a lot in React applications is object destructuring. So let's imagine we have an address object like this. We have street set to some value, city, and country. Now let's say somewhere in the code, we need to extract the value of these properties and store them in separate variables. So this is what we typically do. Constant street, we set it to address.street, and similarly, city, we set this to address.city, and finally country. The problem with this code is, oops, I missed a T here. The problem with this code is that we have this repetitive address.address.address code in multiple places. Destructuring solves this problem. So if we want to have 3 variables or 3 constants, street, city, and country, and we want them to be set to these properties in the address object, we can rewrite this code like this. So constant, we add curly braces. This is the destructuring syntax. We add the name of the target properties, in this case, street, city, and country. We set this to the address object. So what we have on line 11 is exactly equivalent to these 3 lines. And we no longer have that repetition of address dot. So basically, we're extracting the street property from the address object and storing it in a constant called street. Now, you don't necessarily have to list all the properties in the address object. Maybe you're only interested in the city property. In that case, you can drop these 2 other properties. Now, what if we want to use a different name here? For example, what if we want to call this constant st? We can use an alias here. So we add :st. With this syntax, we're defining a new constant called st, and we're setting that to the street property of the address object. So this is object destructuring that you will see a lot in the future sections. Another modern JavaScript feature that we use quite a lot in React is the spread operator. Let's say we have 2 arrays, first with 3 numbers and second with 3 more numbers. Let's say we want to combine these 2 arrays. One way to combine this is like this. So combined, we get the first, call the concat method, and pass the second array. This is the old way of doing things. Now with the spread operator, we can rewrite this code like this. So constant, combined, we create a new array, we spread the first array, and that means we'll get every item in this array and put it in our new array. And then similarly, we'll spread the second array. So the spread operator is represented using 3 dots. Now, in the first glance, you may say, there's really not much of a difference between what we have on line 4 or line 5 in terms of the length of the code. So why is this an improvement? Well, what if we wanted to add an element somewhere in the middle? So we can simply come here and add an element right in the middle. But when using the concat method, if you want to get the same result, our code would end up looking more complicated. Similarly, we can add another element here at the end. So B, we can visually see what the end result will look like. So we have a new array. First, we spread all the items in the first array, then we have A, and so on. So basically, when we apply the spread operator on an array, we'll get each individual item in that array. Now, using the spread operator, we can easily clone an array. Let me show you. So I'm going to comment out these two lines. Let's say we want to clone the first array. We define a constant, clone. We create a new array and simply spread the first array. Now, if we log first and clone, you will see they are identical. Save the changes back in the console. So here's first and here's clone. Now we can also apply the spread operator on objects. So I'm going to rewrite this code, but use an object instead. So let's delete everything. Don't worry, you're not going to forget this. So let's define a constant, call it first. We set it to an object with the name property set to Mosh. Then a second object with another property, job instructor. Okay, now let's say we want to combine these two objects into one object. We declare another constant called combined. We create a new object. Note that previously we created a new array because we were combining two arrays. Now we're combining two objects, so we create a new object. Now in this new object, we want to add all the properties of the first object. So we spread the first object. Then we'll also spread the second object. We can optionally add other properties. Let's say location Australia. Now if we log this combined object on the console, we get this object with three properties. Similarly, we can use the spread operator to clone an object. So if I want to clone the first object, I can do like this. A new object, we simply spread the first object and boom, we're done. Now let's talk about classes. So look at this piece of code. We have this person object with two members, name and walk. What if we want to create another person object that can walk? Well, let me temporarily duplicate this code and call this other object person2. Now there is a problem here. The problem is that we have duplicated the implementation of the walk method. Now this implementation is currently a single line of code, but in a real-world application, this method can be 5 to 10 lines of code or maybe more. If there is a bug in this method, then we'll have to come back and fix it in all person objects. That doesn't make sense, right? So when we have an object with at least one method, we need a blueprint to create objects of that type. And that's when we use classes. So let me show you how a class can help us solve this problem. I'm going to delete the second person object and create a class. So we start with the class keyword, give our class a name, person, and note that here I'm using Pascal naming convention. So the first letter of every word should be uppercase. Now, as another example, if we wanted to call this class cool person, we would have to name it like this. So note that C and P here are capital, okay? So here's our class. Then we add a code block. Now we need to move our walk method inside our person class. So I've selected this code. I'm holding down Alt and then press the down arrow. So we can move it like this. Easy, right? Finally, we need to add another method here. That method is a special method that is called constructor. So just like the walk method, constructor is a method, but the name is reserved. It's a special keyword. That's why, similar to the class keyword, it is orange. Okay? Now this constructor can take parameters. So we can pass the name from the outside and initialize it here. How? Well, we use this. In this case, this always returns a reference to the current object. So we set the name property on that object to this name argument that we receive from the outside. Now we have a blueprint for creating person objects. So let's delete this code on the top. To create a person object, we can do something like this. So person, we set it to a new person object. So this new keyword or the new operator is very important here. When we have a class, to create an object using that class or that blueprint, we need to use the new operator. Now we add parentheses and you can see our name parameter. So if you ignore the new keyword for a second, this expression looks like calling a function. And that's exactly our constructor method in the person class. So the parameters that we defined there, we can set them here. So I'm going to pass Mosh as an argument. Now we have a person object. You can see it has the name property and the walk method. With this person class, we have implemented the walk method in a single place. If tomorrow we find a bug in this method, there's a single place we need to modify. So this is the benefit of using classes. Next, we're going to look at inheritance. Now let's take the example from the last lecture to the next level. Let's say we want to define a teacher class. So class teacher. Here we add a teach method and simply do a console.log of teach. Okay. However, all teachers should be able to walk because they're all persons. We don't want to duplicate this walk method in the person and teacher classes. So how can we solve this problem? Basically, there are two solutions here. We can use inheritance or composition. The explanation of both these approaches is beyond the scope of this course. That's something that I have talked about in my other course, Object-Oriented Programming in JavaScript. But as far as React is concerned, you need to understand the concept of inheritance. So we can have this teacher class inherit from the person class, and this means it will inherit all the methods defined in this person class. How can we do it? Very easy. So here we add a keyword extends person. So teacher extends person. Now, if we create a teacher object, so teacher, we set it to a new teacher. Look at its constructor. You see the name parameter, right? So the teacher class is also inheriting the constructor of the person class. Okay, so let's pass a name here, Mosh. Now teacher dot, look, we have the name property, which we have inherited from the person class. We have the teach method that we added specifically in the teacher class, and walk, which we also inherited from the person class. So this is inheritance in action. Now let's take this to the next level. Let's imagine when creating a teacher, apart from the name, we need to pass their degree. So here in the teacher class, we need to add a constructor. This constructor should take two parameters. One is name, which we need to pass to the person class, and I will show you that in a second. The other parameter is the degree. So degree. Now, because we added a custom constructor here, we need to call the constructor of the person class. If we don't do that, we'll get an error. Let me show you. So down the bottom of this file, let's remove this line teacher dot, save the changes, back on the console. Look at this error, missing super call in constructor. And you can see it's pointing to line 12. This is where we're defining the teacher class. Right after that, we have the constructor. This is where the problem is happening. So back in the code, whenever we add a constructor in a child class, we need to call the constructor of its parent class. So here in the constructor, we have this special keyword super that references the parent class. So we call it just like a method. And you can see here we have the name parameter. So we pass this name argument that we receive here. So this will initialize the name property. Next, we need to initialize the degree property. So this, the degree, we'll set it to this degree argument. Now finally, on line 22, we need to pass the second argument, the degree, that is, let's say Master of Science. So if we type teacher dot, now you can see we have two properties, degree and name, as well as two methods, teach and walk. So this is inheritance in action. As you will see in the next section, whenever we create a component, we should have that component extend the base component that is defined in React. Because that base component in React has a bunch of methods that we need in our components. So we're done with classes. Next, we'll look at modules. So here's the code that we wrote in the last lecture. Currently, this file is getting a little bit bloated because we have multiple classes defined in the same file. It would be much nicer if we split this code across multiple files. And this is what we call modularity. So instead of writing all the code in one file, we write our code in multiple files. We call each file a module. In the old days, we didn't have the concept of modules natively in JavaScript. So there were many third-party solutions. But starting from ECMAScript 6, we have the concept of modules natively in JavaScript. So let's go ahead and modularize this application. I'm going to move each class in a separate file. Let's start with the person class. So create a new file, back in index.js, select the person class, cut it, and put it here. Now let's save this as person.js. Similarly, we need to go back to index.js and grab the teacher class, cut it, create a new file, paste it here, and save it as teacher.js. So now we can see we have less code in each file, and our application is more maintainable. But we're not done yet. When working with modules, the objects we define in a module are private by default. So that means this teacher class that we have defined here is not visible to any other files or modules in this application. In order to make this visible, we have to make it public. And we do that by exporting this class to the outside. So we export it from the teacher class, and then we import it wherever we need it. So doing that is very easy. We simply prefix the class with export. Okay, save the changes. Similarly, we go to the person module. So we need to export the person class because we have referenced that in our teacher module. Here, we're using the person class, right? But currently, we have not imported this person class here. So on the top, we add import, curly braces, person, from, in quotes. You can see IntelliSense in VS Code is suggesting a few libraries like React, React DOM, and so on. These are the libraries that we have specified as dependencies in package.json. So let me quickly show you. Back in the project, here, if you look at package.json, we've got 3 dependencies here. And these dependencies are stored in node modules folder, right? So currently, we don't want to import anything from these modules. We want to import from our own modules. So let's close this. So here we need to pass the relative path to the target file or the target module. We start with period slash, and that indicates the current folder. Here are the files in the current folder. So we want to import this person class from this person file. Note that here we don't add the extension, just the file name. So we don't add .js, okay? And finally, we need to terminate this statement with a semicolon. So we imported the person class from the person module. Finally, we need to go back to index.js. And because here we're using the teacher class, we need to import it. So once again, import, curly braces, teacher, from, relative path, that is period slash teacher. Save the changes. Now to make sure that everything works, let's call the teach method. Save the changes. And here in the console, you can see the teach message. Beautiful. So we successfully modularized this application. In the next lecture, we'll talk about default and named exports. In the last lecture, I told you that the objects that we define in a module are private by default. So they are not accessible from the outside unless we export them. Let's explore this topic in a bit more detail. So here in our teacher module, or teacher.js, I'm going to define a function. Let's call that promote. We don't have any code here, just a simple function. Now save the changes. Back in index.js, so on the top, we're importing the teacher class from the teacher module. Temporarily, I'm going to delete this. Press Control Space. So with the IntelliSense, you can see here we have the teacher class that is exported from the teacher module, but we don't see our promote function, right? So back to teacher.js. If we export this function, now we can import it in index.js. So save the changes, back to index.js. Once again, Control Space. Look, we have the promote function and the teacher class. So we can export one or more objects from a given module. These are what we call named exports. So what is exported has a name, like the promote function or the teacher class. Now, apart from named exports, we also have the concept of default export. And that is the main object that is exported from a module. Typically, we use default exports if there is only a single object that we want to export. Let me show you what I mean. So back to teacher.js. Let me temporarily comment this out. So you can see currently we are exporting only a single object. That is the teacher class, right? Now you might say, but Mosh, a class is not an object. Well, in JavaScript, technically a class is an object because JavaScript classes are syntactic sugar over constructor functions. And functions, as I told you before, are objects. So a class is technically an object in JavaScript. Now that aside, here we're exporting a single object. Now, we can add the default keyword here, and that means this teacher object is the main thing or the default thing that we're exporting from this module. Now with this, back to index.js, we don't need the curly braces anymore. We use these braces only to import the named exports. In this case, teacher is the default export, so we import it like this. Save the changes. You can see our application is still working. We've got the teach message on the console. So let me quickly recap. With default exports, we import them like this. Import whatever from this module. With named exports, we import them like this. We put them in curly braces. Okay. Now it is also possible that a module has a default export as well as a bunch of named exports. React module is an example of that. And I'm going to show you that in a second. So back to our teacher module. Here we have a default export, but I'm also going to export this function. So we have a named export as well as the default export, right? Save the changes back in index.js. So on the top, we are importing the default export. Also, we add curly braces, Control Space. Look, we have the promote function. This is a named export. We can import that as well. Now, why does this matter? This is a pattern that you see a lot in React applications. So as you will see in the following sections, on top of almost every file in a React application, we have an import statement like this. Import React, comma, braces, component from React. You can see this import statement looks very similar to what we have on line 1. So let's see what's going on here. Obviously, React is the module, but note that here we don't have period slash because we use that only for our own modules that are part of the project. But React is not part of our project. It's a third-party library that is stored inside of the node modules folder. Okay. Now React is the default export from this module, whereas component is a named export. So if I delete this and press Control Space, you can see all the named exports in the React module. 99% of the time, we're going to use the component class because we want our custom components to extend this component so they will inherit all the behavior, all the methods implemented inside of this class. Okay, so that brings us to the end of this section. I hope you enjoyed the material and I will see you in the next section.